So what are we going to be talking about here today? What's the main problem we're trying to solve? 87% of machine learning models never make it to production. Why is that? Well, first, let us introduce ourselves. I'm Louis Huard. I'm a data nerd. I'm the senior product manager at Zepl. I, in the past, have been an investigative analyst. I've been a data scientist and a product manager at AI startups and at large enterprises like Cisco, AppDynamics.
I'm Moon. My background is software engineering, and I'm founder and CTO of Zepl, and also I'm a creator of Apache Zeppelin, a popular open source data science notebook.
Just a little bit about Zepl. Zepl is the data science and analytics platform for your entire team. Analysts, data engineers, data scientists, team executives, business people. Everyone has a space for Zepl. Zepl is a platform that provides a single place for people to do data exploration, collaborate together in a secure environment with the support of an entire company behind you to kind of provide you those updates that you need to solve your biggest problems. As far as what tools do we integrate with our platform, we think of Zepl as the glue that stitches together all of your existing tools that you've already invested in or gotten familiar with. So whether there are languages like Python, SQL, R, Flink, Scala, Spark, whatever one's going to be coming down the pipeline, ML libraries such as TensorFlow, Caffe, data sources, we're able to kind of stitch together all of the disparate parts of your data science ecosystem in one simple pane of context where everyone is able to learn and start working together.
So let me go a little bit about our history, where we came from and where we got these challenges. So we have started Apache open source Zeppelin open source project back in 2014. And since then, Zeppelin got more than 500,000 downloads worldwide, and we have a lot of users and companies who love Zeppelin. And that gave us, we also got a lot of enterprise demands, such as enterprise level security and access control, as well as scalability and stability. And we founded Zepl and launched Zepl Data Science Analytics Platform last year. And we had an opportunity through open source projects, Zeppelin, Apache Zeppelin, and Zepl. Through this product, we have an opportunity to work with the top data scientist team in the most innovative companies in the world. So we have chances to looking at those teams, and we have chances to learn their problems and challenges. So back to our questions: why 87% of machine learning models are never making it to the production? So Louis, what do you think? What are the challenges here?
Well, the quick answer is that your machine learning model, the code you actually build, is just a tiny drop in the bucket in terms of putting everything together and actually pushing a model to production. You've got to make sure you have access to data. You understand serving infrastructure. You know how to monitor your model once it's up there. These are all things that are outside of the skill set of the typical data science, not even factoring in the human element, which more than anything corrupts, corrodes, and degrades this elegant moving of models to production. When we look at the life cycle that people typically go through when they're developing these models, they start with identifying problems. They start with preparing their data, forming a hypothesis, building the model that really proves their proof of concept. All these steps have to flow seamlessly before you're actually able to move a model to production and start monitoring. But at every step of the way, things can go wrong. When data prep, you have to understand, how does all your data connect together? How does everything link through things like data dependencies? You have to understand how the complexity of your model ultimately manifests to how quickly it's able to operationalize and return answers to your consumers. There are language restrictions. You can't always, the language you prototype in isn't always the language you're able to actually push your model to production into. Finally, you built a beautiful model, but it doesn't actually run on anyone's computer but your own. It's not reproducible. How do we work around that? And ultimately, even if you have a model ready to move to production, who owns that model when it moves to production? Who takes care of it? Who nurtures it? And how do you test and train and deploy that model as it goes through upgrades and you adopt your thinking around it? And finally, how do you actually monitor this thing? So Moon, why don't you take it off and tell us a little bit more about data dependencies?
Yeah, data dependency is important because of any model, you probably start from the data. So, but many models of course, depends on the data, and sometimes multiple different data set, and sometimes even output of another models. And that means your data set have multiple consumers, and that's okay. But if your data set might changes over time, the distribution of your inputs, or sometimes the mapping, label mapping might be different. Sometimes the meaning of the columns can be different, adding more columns or more information in the data set. So that every single changes on your data set may impact your models, and you want to know when you have update on your data set, what model can be impacted. So this simple dependency information need to be managed somehow, some way. Otherwise, if you have 100 of different data set and thousands of different models, it becomes really, really complicated in the end quickly. So one thing that you want to start is, of course, you want to keep maintaining a versioned data set, of course. So you know which version of data is being used for which version of your model. But that's not enough. That doesn't contain all the information about the dependencies. So where do we want to keep those information about the dependency between data and the models? I think a natural place that we can put those information is a data catalog. If you have a data catalog in your team, data catalog usually have an name of data set and physical location of data set, such as S3 buckets or database name and the table, and the schema of data, like a field name and their types. But if your data catalog allows you to annotate some additional information, you can annotate that, oh, this data set consumers are model A, B, and C, or any other information you can add. So there can be sometimes you can custom build your catalog to include to manage that dependencies. So any catalog or any system that is accessible from the team and searchable, you want to search the dependency and you can annotate that information, is going to work. But if you don't have that system today, there is a quick solution I would like to suggest. So one quick solution is if you are a small team and you like to start managing this information today, then you probably can start managing dependencies through the data science notebook. So I can assume that your data scientists are familiar with data science notebook, and data science notebook is flexible enough to include these informations. You can annotate anything you want in the markdown cell. And if you have a sharing system, and that means you can share this catalog across your team and anyone can search the information. And additional benefit of using notebook is notebook is programmable. You can write Python script or Scala, any programming language you like, and that means you can generate a schema inside notebook programmatically, and you can generate preview data inside of here. So every time you update your data set, then just run the notebook, and every catalog is automatically up-to-dated. And once you load the data, and then next thing you do is you probably experiment and train your model. And here model complexity comes. So Louis, what's the challenge around the model complexity?
Yeah, great question, Moon. So, you guys are probably familiar with this diagram. It comes up a lot when we think about overfitting and over-designing and overbuilding a model. Typically, what gets proposed as the best complexity is the one that minimizes the amount of testing error as compared to the training error that you receive. But especially when you're moving models into production, that local optimization might not be the appropriate one. You have to think about the cost-effective complexity necessary to kind of solve your problem. And what do I mean by that? So typically the holy grail, the pinnacle of quality is helping people building accurate models, highly predictive models. But when you're moving things to production, that predictability may go to waste if it's not cost effective and if it doesn't deliver the results in the time window that's necessary to actually be actionable. And this isn't always something that data scientists are truly equipped to kind of deal with. You have to factor in aspects of how much load is my model going to get. Really hard to predict as you're designing. How much infrastructure do I need to get? Impossible to know without knowing how much load you need. And how do I evaluate this and factor and do the cost-effective analysis? Is this model worth putting into production? Again, really challenging problems. And you have to really assess how much the mistakes you're making in your model really cost from a business perspective. So these are that's a common pitfall we see a lot of the time. But along that lines, with really complex models, there are a lot of things that run on my computer that won't necessarily run on Moon's computer. Actually, most likely the other way around. So Moon, why don't you tell us about challenges in reproducibility?
Yeah, I think a lot of people here probably experience this situation at least once. So, my code runs perfectly fine on my computer and it doesn't run on other people's computer or gives a slightly different result. And it applies to not only software engineering, but I think it also applies to data science and data science notebook as well. So where this reproducibility problem comes, actually reproducibility is really important if you want to iterate your machine learning model development. If you want to keep improving your model's performance, reproducibility is really important. So I think there are three different main sources of this problem. So first reason is, I think, a runtime environment. Your operating system libraries, or your Python libraries, or your framework version can be different from, not identical from other people's computer. And the second reason is resource availability. Your model may require a certain amount of resource, such as memory, and sometimes require special hardware like a GPU. So I have enough resource to run my model, but other computer may not have that resource. The last reason is data availability. So sometimes my notebook loads data from database or S3 bucket or some data source, but I have a credential and an access control. I'm in the access control list and I have a credential to access that data source, and I have configured my network to all the way down to the actual data source from my laptop. So I have no problem, but maybe people next to me doesn't have that credential or doesn't have access, network access from their laptop to all the way down to the data sources. So these are things make notebook or data science work really difficult to reproducible. And I think a solution is for the runtime, I think we can just containerize the entire environment. That's it. I think common practice nowadays. So we can make sure there is the same operating system and system libraries and all the Python and dependencies are exactly the same every time. But resource availability and data availability is hard to solve inside of our laptop, I think. So solution here is bring that containerized environment to the server side from your laptop. Actually, that really helps and makes sure that everyone can access the same resource, as well as have a same opportunity to access the data source. And this is not only help reproducibility, actually it also helps security as well, because you don't have to access the data source directly from individual people's laptop. That actually dramatically improve the security management. And here is a little tip about writing reproducible notebook. I think every notebook, either it's Apache Zeppelin, Jupyter, or any other notebook, most of the notebooks nowadays provide a capability to configure your environment inline, such as environment variable or your JVM properties or properties of your library framework. So I think if your environment is already containerized and running in the server side, I think it really makes sense to configure your data science environment inside the notebook inline, and you can also install dependencies inline. Once you've done your job, you can print out programmatically. You can just print out and document all the dependencies that you are using inside the notebook, and so that this notebook is suddenly becomes really highly reproducible. So everyone can have the same configuration, same version of library, and we even documented what is dependencies inside the notebook. And when we are writing a model, of course, we use languages and framework. And there's some challenges around this area. And Louis have a great experience here. So Louis, can you share some of your experience here?
Sure, absolutely. So one of the most challenging non-reproducible experiences that you'll meet is when in a corporate environment, you're actually not allowed to choose the language that you want and you have to rewrite something completely. So in my last company, Perspica, we were acquired by Cisco AppDynamics, and we were an AI ops company, and we built a machine learning model that did anomaly detection and baselining at scale for millions of metrics. It worked really well. We integrated into AppDynamics, one of the happiest days of our lives, and we then spent the next 12 months actually integrating our model, rewriting it completely in a new language. And every time we scaled up the team and had to, there was one transcription error. Sometimes it would take weeks to just diagnose these little errors that happen when copying things from one implementation to another. So not something that typically you think about when you're prototyping, when you're building something, when you're self-managing, but once you really start embedding analytics into your product and need to think about how it gets deployed and what restrictions you have on those environments, you start to really run into firewalls in terms of what you're allowed to run, where you're allowed to run it, et cetera. So important to kind of think about where this is ultimately being deployed and what type of restrictions are going to be in place there. But even if once we successfully deployed our model, one big concern was how do we monitor this thing? How do we keep track of everything that's going on?
Yeah, I think once you deploy your model to the production, there are a lot of different things you can monitor. Maybe performance of your model, your accuracy errors, or latency of your model, or computing, whatever, memory. But let's say if you can monitor only one metric, then what would you like to monitor? What is the most important metric for you?
My answer was revenue, but.
Okay, yeah. If you can monitor two, then what would you like to monitor? The second most important thing for you. I think my answer is prediction bias. So prediction bias, I can explain prediction bias. The definition is basically distribution of a predictive label is usually equal to distribution of observed label. What does that mean? Let's say I'm making a spam classifier, spam mail classifier. So my model is classifying email, whether it's a spam mail or it's not spam mail. So, and let's say I know the word in current world that we are living, about 1% of email is spam, and then. Regardless of accuracy of my models is supposed to classify about 1% of entire email as a spam. Maybe my model just randomly picks, or my model have a very high accuracy, like 99.9. Regardless of that, only 1% of email need to be classified as a spam. That's the meaning of prediction bias. So what can happen without monitoring prediction bias? This is I googled one example from the internet. I think this is a good example. So there were a high frequency trading company, and their model one day start to lose $10 million every minute, and that went on for 45 minutes, and they end up with losing $440 million. And if they knew that, let's say, oh, whatever happens, my model in the real world, my model cannot lose more than $2 million, $20 million in 10 minutes, let's say, and then if they were monitoring that, they could able to stop their, they could able to get an alarm, and they could able to manually engage before the model lose all the money in the company. So I think this is one metric, but I think it depends on your model, your case. Actually, prediction bias can be really important in one case. Another case, there can be another metric which is more important. So the thing here is deploying your model is not the end. You actually have to have a system to monitor how your model is performing, and you need to keep improving your model based on the monitored metrics. And we have some challenges around model ownership. And Louis, can you explain what model ownership means and what are the challenges here?
Absolutely. So building on that high frequency example, a big trading firm has lots of handoffs, and the person who is developing the model isn't usually the person who's managing and running the model. And when you have a self-managed kind of model, you can let a lot more incompleteness fly. You don't have to document as carefully. You really understand your model intuitively, and you know its pitfalls and its challenges, and you don't stress it in certain ways. You're able to look out for the baby that you've created. But when you start working as a larger team and start thinking about all of the different handoffs that need to take place, after you develop your model, you hand it off to your security auditor who's going to make sure that you can't get attacked, who's going to hand it off to the DevOps guy, who's going to deploy the right infrastructure for your model to run, who ultimately then releases it to the user. There's a lot of information that gets lost in that game of corporate telephone. And even ignoring the field of data science, every time you start doing one of these handoffs, you lose 50% of information in each handoff. So once you start building these really complicated internal bureaucracies that govern and limit who's responsible for what part of model ownership, you run into a lot of pitfalls, and you really need to have everything be really tight before you hand it off to reduce the information loss that you have from every single handoff. So when you develop a model, you're not always the one who's going to be running it, and that's going to cause you some trouble. So get thinking about documenting quicker. But documenting is just part of the battle in fighting this. One of the best ways you can really do this is to have good tests for your model before you deploy it. So Moon, why don't you tell us how other companies are doing this?
Yeah, I think nowadays there are a lot of good frameworks, tools, services that helps your machine learning pipeline. In the open source side, Kubeflow, and there are many others. And in the service, we see Amazon SageMaker trying to provide end-to-end machine learning pipeline. And they are good, actually. But with that, is it good enough for data scientists to maximize their output, or is it easy enough to data scientists to use to put their model to the production? So these are a good solution today, but still data scientists need to have some understanding about the underlying infrastructure, Kubernetes, how they work. I need to write some manifest to use some open source, or I need to use some proprietary API to use certain services. I need to import some particular library to deploy some particular framework. So can we really quickly, can we help data scientists to make data scientists really quick, have a quick iteration of their machine learning model development? So we, from that, with that problem, we started some research project with the open source community and our user. And basically what we, the idea is because of data scientists likes to, they experiment inside Node a lot of times. And if we just let them deploy that actual Node to the production as a model, then many things can be solved in this way. So let me actually show you actual implementation. And let me increase some Yeah. So this is one very simple example of one notebook. I intentionally didn't made it really complex because I wanted to share essential thing that I'd like to show from model to the production. But in a real life case, you probably want to import your favorite library like TensorFlow and PyTorch or Spark, MLlib, or Ray, or whatever you like to build your model. So you can train your model inside Notebook. It doesn't take too much time, or you can load pre-trained model here. But regardless, let's say in the end, I came up with my prediction function. Let's say I wanted to build my binary classifier for the email to classify it's spam or not. So here is my spam classifier function. And in a real life case, of course, it's not going to look like this. But let me, to highlight the point. Input is probably a string, email contents or the title, and an output is Boolean value, true or false. And optionally, I can write any unit test here to make sure my input is the correct format and my output is correct format, or any other test I want to automate here. And in the end, I can register my classifier with the endpoint name. That's all I need to do. So I just need a regular Python function. I don't have to use any particular library. I don't depend on or lock in any other technology, but I can use whatever I want, but only thing I need is I need to write this Python function. And one thing I can do after I write Python function is, let's say this is a release candidate 1. I can version this version RC1, and then I can run tests. The testing data science notebook is not the common concept today. But I think automated test is a very common concept in the software engineering, and that actually helps iteration of rapid development. So I think it also makes sense because data science is also done through the code. So I think it also makes sense to adopt that concept. So we introduced testing capability here. So I can just click the test and test it. When I click the test, it automatically packages my notebook and spin up one container in the cluster, and it runs tests in the background. And actually, this is they are all running in the Kubernetes cluster. And let me see. Yeah, I think test is passed. There is a little bit of a misalignment on the icon, but test is passed, and we can see test results here. So because I don't want to deploy anything in the production that is not tested or that is not automatically tested. So once my notebook is passed the test, all I need to do to bring my model to the production is click this button, start serving. So I click this button, and then again, in the background, the system packages everything into the Docker container, and that system deploys that container to the Kubernetes. So to make sure it's scalable and fault tolerant. So once a container is deployed, let's see, we can see there is a serving pod is actually created in the Kubernetes cluster. And then if I go to the serving tab, I see there is an endpoint created with ending with spam, and this endpoint is a REST API endpoint, so I can send some message to the endpoint, and my input is nice to meet you, and let's see what results I can get. I got true because my Python function is returning binary Boolean value, so I get true. In case of I'm writing just ABC, oops, maybe I'm getting false. So we can see I can actually write a simple model and deploy with a single click to the production, and I can call that model. And once I call that model, and we can see metric data here. Metric data are automatically collected, so number of requests, latency, and some additional metric. I can actually put custom metric data. Actually, the second return value, second item in the return value is actually a custom metric dictionary. So I can put any metric I want here. So this is one research and experiment that we did together with open source community and our users. So we believe this is this way we can dramatically help many problems that we have mentioned before. And we are planning to have this feature. We are planning to bring this feature in our product. Also, we are planning to contribute this feature to the open source community.
So that was a really cool demo. Thank you, Moon. So some of the takeaways that we have, how do you achieve this holy grail of data science of rapid model production? You got to think beyond the algorithm. You have to think about the trade-offs necessary, the human element, the infrastructure. Think of it all kind of together. And you also have to recognize what works in dev will likely not immediately work into production. You're going to have to do a little bit of work and maybe bring some other folks in to get it deployed successfully. So no working alone on these kind of things. And finally, you have to apply software engineering best practices to data science. Software has gone through this problem 15, 20 years ago. We're trying to do whatever we can to learn from those best practices to reduce these kind of faults from happening in the future. So that's what we have for you guys today. Thank you very much for attending. We're at booth 316. Any questions from anyone in the audience today?
When will this new feature be available in the open source?
Yeah, the good question. The question is when the model serving feature is available in the open source side. Actually, the source code is already in public, so there is a pull request I created, and that's in the review. And hopefully, it's not completely reviewed and merged to the master branch, but today, actually, you can try build that pull request, and you can try it today. And hopefully, we can include this feature in the upcoming release, which is going to be 0.9 release.
Great. Thank you everyone so much for attending. It was lovely to have you.